Hey class, let's jump into the explain portion of our lesson. You need your notebook and writing utensil. I'm just going to skip over these slides. This is what the heading should look like so far. When you see the Bitmoji, you need to write notes. We've seen this table before. Pause the video, take 30 seconds, look over it, and then I'm going to ask a check for understanding question about it. So here's the check for understanding. What is the charge of the nucleus? Hint, what subatomic particles are within the nucleus? Now, pause the video, answer it. I am going to go over the answer in a moment. All right, so the charge of the nucleus. I go to the nucleus and I see that there are protons and neutrons. The neutrons are neutral, meaning they have no charge. Protons are positive. Therefore, in the nucleus, we only have a positive charge. The answer has got to be A. Now take a moment and write the element tile. This is an element tile of copper, Cu. Subatomic particles can tell us about the element's identity. The chemical symbol of copper is Cu, and above it you see the atomic number is 29. Now, in an atom of copper, it has 29 protons. Every atom of copper has 29 protons. Symbolic notation takes that idea a step further. It's the way chemists across the world talk about atoms. Now, the symbolic notation on the right side of your screen is a notation of carbon. The mass number is the top number. The atomic number is the bottom. Mass number is protons plus neutrons, while atomic number is just the protons. There's an important distinction to make. In a tile, like you'd find on the periodic table, the atomic number is on top. Whereas in symbolic notation, the atomic number is always on the bottom. Now, we're going to use this symbolic notation to answer the question, how many neutrons are within this atom? Mass number is 13. Atomic number is 6. The neutrons would be mass number minus the atomic number. 13 minus 6 equals 7. So there's got to be 7 neutrons in this isotope of carbon. And we'll learn what isotope means in a moment. Pause the video and try to answer this check for understanding, given what we've looked over before. How many neutrons are pictured in the carbon atom to the right? Remember, mass number minus atomic number equals the number of neutrons. Go ahead and pause. All right, 14 minus 6 equals 8. Our answer is C. Now that you've seen a couple examples of a symbolic notation, it's time to write some. Now, I took this tile off of the periodic table. Remember, the top number is the atomic number or number of protons. This is our element symbol. There's the name. Don't worry about this bottom number. It's the average atomic mass, but we'll talk about that later. Here are the steps. First, I'm going to write the symbol, then the protons, then the mass number. Let's do this example of lithium with 3 protons and 5 neutrons. First, I'm going to write my element symbol, lithium. Do not capitalize both letters or lowercase both letters. It has to be big first letter, small little letter. That's just how it is. Now, protons is 3, and mass number is neutrons plus protons, 8. We have a second symbolic notation. It's oxygen. Pause the video, try to draw this one for yourself, then we'll go over it. Oxygen, according to this tile is just shown as O. There are 8 protons and 9 neutrons. So 8 plus 9 is 17. Take 30 seconds and look over all of this. Your third CFU is going to be to match the correct description with the correct symbolic notation. All right, let's go over this. Protons, we need 6. So I'm going to look at the bottom and find which ones have 6. I know these two have got to have it. The neutrons also are 6. So I'm going to think, okay, I need to add those two numbers together, protons plus neutrons. So 6 plus 6 equals 12. It's got to be that bottom one. I'm going to do the same thing. Protons 6, neutrons 7. 6 plus 7 is 13. That's got to be that one. Finally, our protons are 9, neutrons 10. 9 has to be on the bottom. 10 has to be not on top. 10 plus 9 is on top. So that has got to be our answer. Finally, look at the symbolic notations and ask yourself, how are they similar? How are they different? Pause the video, try to answer those questions. Now, there are a few things you might have asked yourself or noticed, but what we've got are 6 protons per each carbon atom. However, they have different mass numbers. You notice it's got 12 and 13 and 14. These are isotopes, atoms with the same number of protons but different neutrons. Stop and answer, how many neutrons are present in each one of those carbon atoms? Remember, the formula is mass number minus atomic number. All right, let's see how you did. I need to do 12, mass number, minus 6, carbon's protons. That is going to be 6 neutrons. Next one is 7 neutrons. Did the same thing. And finally, 14 minus 6 is 8. That concludes the explain portion of this lesson. Thank you so much.